Hi everyone, Assalamualaikum. In this video, we will continue with evaluating composite inverse trigo functions using triangle method, right? Alright, we're still under the second topic in chapter 1, which is evaluating inverse trigo function using triangle method, alright? Alright, now we look at example 2, okay? Without using calculator, evaluate cos inverse sine half. Okay, from the previous video, we discussed about composite function between same trigo. One of them is inverse and one of them is ordinary. Okay, but how about if we have different trigo? Okay, let's say we have composite between ordinary cos and inverse sine half. In this case, we cannot use the properties, okay? But we need to use triangle method, okay? Alright. From the procedure that we have been discussed in the previous video, this is the procedure to evaluate inverse trigo function using triangle method. We have 5 steps, okay? Step 1, we let A equals to inverse trigo function. Okay, so from step 1 here, okay, A equals to inverse trigo function means A equals to inverse sine half. Okay, this is our A. Okay, then we continue with step 2. Okay, change the inverse trigo function to ordinary trigo function. So means that we move inverse trigo function here, we move inverse sine to the left hand side. So we will get ordinary sine A, okay, equals to half because we move inverse sine here. So on the right hand side now, we have half, okay. And then from here, okay, we continue with step 3. Okay, draw a right angle triangle and determine all the 3 sides based on the trigo function obtained in step 2. So this is under step 2. Okay, so based on sine A equals to half, we can draw a right angle triangle with angle A here. Okay, alright. From sine A equals to half, 1 here means opposite. Okay, so we can write 1 here. Okay, and then 2 means hypotenuse because sine equals to opposite over hypotenuse. So we can put 2 here. Okay, and then we need to find the other side using Pythagoras theorem. Okay, so using Pythagoras theorem, okay, we take the longest one, okay, which is 2, okay, 2 squared and then minus 1 squared square root. After we simplify, we get square root of 3 or set 3. So we can put here. Okay. Alright. After we determine all the 3 sides from the right angle triangle here, we can continue with step 4. Okay. Find the relevant trigo ratios from a right angle triangle obtained in step 3. So from the right angle triangle here, we now find all the 3 sides from here. So we can list down all 6 trigo ratios. Okay, but we just write the relevant trigo ratios only. Okay, what is relevant trigo ratios? From the given question, we have cos here. Okay, we done find sine. So now we find cos. Okay, so from here cos A, why we get A here? From this right angle triangle or from here. Okay, this is our A. Okay, so cos A from the right angle triangle here equals to sec 3 over 2. Okay, sec 3 here means adjacent. Okay, and 2 means hypotenuse. Okay, so we have cos A equals to adjacent over hypotenuse. That's why we get this. Okay, sec 3 over 2. Okay. Alright, now we in step 4. Find the relevant trigo ratios from a right angle triangle obtained in step 3. So this is our right angle triangle with all 3 sides. Then we can write a relevant trigo ratios, okay, which is cos A. Okay. And after that, we continue with step 5. Evaluate the given question. So the given question is cos inverse sine half. Okay, so now we can evaluate the given question. Alright, from step 1, we let inverse trigo function equals to A. Okay, so now we have cos A. So we can write equals to cos A. And then from here, our cos A equals to sec 3 over 2 from the relevant trigo ratios that we find in step 4 just now. So our cos A equals to sec 3 over 2. And sec 3 over 2 here means cos inverse sine half. So this is the given question, okay, from here. And this is the final answer. So means that cos inverse sine half equals to sec 3 over 2 without using calculator. We just leave the answer in fraction and sec because we solve without using calculator. Okay. In this case, without using calculator means we use triangle method. We also can check the final answer using calculator. But if we use calculator, we get the answer in decimal. Okay. If the question is without using calculator, so you must leave your answer in fraction or maybe in sec, right? Alright, now we continue with example 3. Without using calculator, evaluate tangent composite with inverse sec 2. In this case, we cannot use the properties of trigo function because we have composite between different trigo function. Alright, one of them is ordinary tangent and one of them is inverse sec. Okay, so to evaluate this function without using calculator, we need to use right angle triangle. Okay, now we look at the solution. Okay, we refer step by step. Okay, step 1. Let A equals to inverse trigo function. So from the given question here, the inverse trigo function is inverse sec 2. Okay. We must take 2 because 2 come together with inverse sec. Okay. So now we let inverse sec 2, which is the inverse trigo function, equals to A. Okay. So let A equals to inverse sec 2. Then we continue with step 2. Okay. Change the inverse trigo function to ordinary trigo function. So from here, we move inverse sec to left hand side. So we will get ordinary sec A equals to 2 because we move inverse sec to left hand side. So now on the right hand side, we only have 2. Alright. So after that, we can write sec A equals to 2 over 1. Okay, 2 here means 2 over 1. Okay, this is reciprocal function. So too easy to draw a right angle triangle. Okay, we can change using reciprocal trigo identities. Okay, sec here means reciprocal function for cos. So means that we can write cos A equals to, we exchange numerator and denominator, so we get cos A equals to half. Okay. Alright. After that, we continue with step 3. Okay. Draw a right angle triangle and determine all the 3 sides based on trigo function obtained in step 2 here. So from trigo function cos A equals to half, we can draw a right angle triangle. Okay, so this is a right angle triangle with angle A. Right, 1 here means adjacent because this is cos. Okay, so we can write here 1. Okay, and 2 here means hypotenuse because cos equals to adjacent over hypotenuse. Okay, after that we can find the opposite side using Pythagoras theorem. Okay, so using Pythagoras theorem, we take the longest one, which is 2 squared minus 1 squared square root, and simplify, we get equals to square root of 3 or sec 3. So we can put here. Okay. Alright, after we find all the 3 sides for the right angle triangle, continue with step 4. Right? Find the relevant trigo ratios from a right angle triangle obtained in step 3. Right? Alright, actually from the right angle triangle, we can list down all 6 trigo ratios because we already know all the 3 sides. Okay? But we just need to take the relevant trigo ratios only. Alright? Alright, from here, from the given question, we have tangent here. So it means that the relevant trigo ratios from the right angle triangle here is tangent A. Right? Tangent A equals to opposite sec 3 over adjacent. Okay? Sec 3 here means opposite. Okay? 1 here means adjacent because this is tangent. Alright? Right, so this is opposite and this is adjacent. Okay. Right, after that we can simplify and we can write sec 3. Right. Right, and then we continue with step 5. Okay. Evaluate the given question. Okay. Right, from here the given question is tangent inverse sec 2. Okay. So therefore tangent inverse sec 2 equals to, right, we refer step 1 from the previous slide. Our A equals to inverse sec 2. So we can write inverse sec 2 equals to A. So now we can read as tangent A. So we can write here. Okay. So tangent inverse sec 2 equals to tangent A. And from here, tangent A equals to sec 3. Okay. So this is the final answer, which is equals to sec 3 because this is the value for tangent inverse sec 2, which is the given question. Okay, we find sec 2 without using calculator and we use right angle triangle because we have different trigo ratios here. One of them is tangent and one of them is inverse sec. Right? Alright, up to this point, you can try tutorial 1.1. Okay, here are 8 questions involving inverse trigo function. You solve it without using calculator. Right? You can upload your answer in Google Classroom. Okay? Thank you. Coming up next, more examples involving evaluating and simplifying composite inverse trigo function using triangle method. Okay, if you like this video, you can subscribe. Thank you for watching. Stay tuned. Bye. Assalamualaikum.